All right, there. Let's continue on with lesson 1 in chapter 11. We'll talk about blood clotting. So, platelets, or what we call thrombocytes, are responsible for creating this web. All right, you see here. This is a fiber, a proteinous fiber called fibrinogen, which is involved in trapping red blood cells, and the platelets are in there as well, and creating a plug basically for a bleeding blood vessel, right? What else can bleed? Blood vessels bleed. Okay, so so it's there to stop bleeding, right? So don't worry about thrombus and embolus. All right, we're not going to quiz you on that at all. So steps in blood clotting. There we go. So it'd be good for you to write this out as I'm talking as a flow chart. So write out the parts. Pause. So I'll teach something. You pause the video. You write out the parts. Okay. So collagen fibers from damaged blood vessels. So collagen is a protein. It's a rope-like protein which strengthens our blood vessels. Okay, collagen is all over the body. It's one of the main binding proteins that we have. It runs through our skin and helps to keep our skin um, tight and yet elastic at the same time. It's in our bones, it's in our ligaments, it's in our muscles, it's everywhere, okay? So this fiber from damaged blood vessels attracts platelets to collect at the site of injury. So you can imagine the collagen fibers there. They're like ropes and they've been cut and they're all frayed, and the platelets are going to stick to the collagen fibers, okay? And when the platelets stick to the collagen fibers, they're going to release a little chemical called a clotting factor. Okay, well, the clotting factor is the chemical, but that's called thromboplastin. Okay, and it releases that from this site, right? So again, the collagen fibers are exposed. They're like frayed ropes. The platelets attach to them. They stick to them, and when they stick to them, they release a chemical, a clotting factor, and that one's called thromboplastin. Now, calcium is in the blood, and so is vitamin K already. And so calcium and vitamin K are used by thromboplastin, okay? And this is a little bit weird, okay? To cause a soluble plasma protein, prothrombin, to be converted into an active enzyme thrombin. So all of these together, all right, will open the active site of of prothrombin to, and then we call it thrombin. So prothrombin, active site closed. Thrombin, active site open. Allosteric activity, thromboplastin, calcium, vitamin K. If you don't remember this enzyme lesson, then go back to the enzymes where I'm talking about inhibition, okay? And then you'll see that this inhibition is going the other way. This is actually activation. So this is called allosteric activation. Now, this enzyme then active around the site of the blood clot will then convert this fibrinogen protein, which is inactive. There's another now inactive protein, all right, in the blood, into fibrin. So fibrinogen is soluble in water, so it can move around easy with the blood. But once it's turned to an insoluble form, it's going to act somewhat like fat, and it's going to stick to the sides of the blood vessel. Now, as it sticks to the side of the blood vessel, it starts to create the clot. So this is fibrin right here, okay? And you can see again the fibrin web around these red blood cells, which are also getting trapped in the web. Okay, that's very it's hard to teach this kind of step-by-step um, uh, biochem to you online. So we'll also look at this and we'll draw a flow chart out together of it um, in group work or in class. Okay, cheers.